Hello friends, welcome to Engineering Funda family. In this video, I will explain convolutional code with great clarity. Here, I'll consider one example and based on that example, I will calculate each and every parameters of convolutional code. You can observe in this example, I will explain constraint length calculation, code dimensions, code representation, code rate calculation, states identification, output calculation with given message. I will also explain code tree, code trellis, and state diagram. So here I will explain each and every parameters of convolutional encoder. So first of all, let me explain the encoder here. See here with given convolutional encoder, message input is given here. This message input is M2 and this message input that we give it to flip-flop 2, output of flip-flop 2 that is M1 and this M1 will be input to flip-flop 1 and output of flip-flop 1 that will be M0. So with respect to input message, bits are getting shifted in this direction. So let us say you are giving first input over here. So with next input, first input will come over here and whatever M1 is there, that will come over here, right? So with respect to message input, there will be change in M0, M1 and M2. Here if you observe output, then output is X1 and X2. This output X1, that is addition of M0, M1 and M2 and output X2 is addition of M0 and M2. Remember, here we perform modulo 2 addition. Modulo 2 addition means XOR operation. So first of all, let me explain what is constraint length. See, constraint length that is denoted by capital K and constraint length calculation is based on number of memory elements. If you have m number of memory elements, then constraint length will be m plus 1. Here m is number of memory elements. Here you can observe we have two flip-flops. So here we have two memory elements. So one can say constraint length that is 2 plus 1 means 3. Now let me explain code dimensions. See, code dimensions that is represented by small n comma k. So first of all, you need to understand what is small n and what is k. See, small n is number of outputs at a time. You can observe here with this encoder, we have two outputs, x1 and x2. And here this small k, that is number of inputs at a time. So if you observe here, at a time we have one input, that is M2. So based on that, one can say here we have two outputs and one input at a time. So code dimension is 2, 1, right? Now let me explain next parameter, that is code representation. See, code representation is small n, comma small k, comma capital K. I have told you capital K is constraint length and n comma k, that is based on number of outputs and number of inputs. So code representation that is there as per small n, comma small k, comma capital K. Here small n is 2, small k is 1 and capital K constraint length that is 3. So code representation is 2, 1, 3, right? Now let me explain next parameter, that is code rate. See, code rate that is denoted by small r and that will be a ratio of number of inputs at a time divided by number of outputs at a time. Here we have one number of inputs at a time and here we have two number of outputs at a time. So code rate will be half. So one can understand this. See, here if you have 1 bit input, in that case here our output will be of 2 bits, x1 and x2. So with respect to 1 bit, here there will be 2 bits of output. So one can say code rate is half, right? Now let me explain next parameter, that is states. See, states are defined based on memory elements. Here you can observe we have two memory elements. Output of first flip-flop, that is M0, and output of second flip-flop, that is M1. So this M0 and M1, that will define states, right? So one can define states based on memory elements. Here we have two memory elements. First is M0 and second is M1. So based on two elements, there will be in total four states: 0, 0, 0, 1, 1, 0, and 1, 1. Let us give name to it. So here with 0, 0, state will be small a. With 0, 1, state will be small b. With 1, 0, state will be small c. And with 1, 1, state will be small d. Right. So that is how one can understand states. Always remember, see this flip-flops, that is holding states. Output of flip-flop, that will be state. M0 and M1, that will define state. This M2 is message input, right? Now, let me explain output with message 110. So to understand output with message 110, first of all, you need to understand how this circuit functions. See here with this circuit, when you insert first bit, at a time, this M2 will be shifted over here and this M1 will be shifted over here. When you insert second bit, then again there will be shifting operation, right? Initially, you should consider M0, M1 and M2, that is 0. So now what I'll do is I'll explain you calculation of output with message 110. So first of all, this M0, M1 and M2, initially it will be 0, right? But when you insert first bit, that is 1, then that will be given to M2. So here we will be having M2, that will be 1. And previously we were been having 0 over here, 0 over here and 0 over here. So that is getting shifted in this direction. So now here we will be having 0, 0. Now when you insert second one, right? See first one that we have inserted. Now when you insert second one, so that second one that will be coming over here. Now this M2 that is getting shifted over here. So it will come over here. And this 0 that is getting shifted over here. So that will come here. And this 0 that is getting discarded, right? So that is how shifting will happen. Now when you have next input, that is 0. So that will come at M2, as M2 is current bit, that is 0 now. Now previously here we were been having 1. Now that is getting shifted in this direction. So it will come at M1. And this M1 that will come at M0. So here we will be having 1. And this 0 that is getting discarded. Now even if you don't give any input, right? Let us consider we have input that is don't care. So in that case, with next input, what will happen? This 0 that is getting shifted over here. So it will be at M1. This one that will get shifted to M0. And this M0 that is getting discarded. So that is how things are getting repeated with respect to input message. Now our question is to understand output. To understand output, first of all, you need to understand what is our circuit. If you observe here, output is x1, x2. What is x1? X1 is addition of M0, M1 and M2. And what is x2? That is addition of M0 and M2. So first of all, let me note it down. See, x1, that is our output, that is M0 plus M1 plus M2. And x2 is our output, that is M0 plus M2, right? Now, if you observe this data 0, 0, 1, then what will be our output here? If you talk about x1, x2, that is our output. Then x1 is addition of these 3 bits, that is 1. And this x2, that is addition of M0, M2. So that is again 1. Over here, if you talk about output x1, x2, then x1 is addition of these 3 bits. So 2 times 1 means 0. Here we are performing XOR operation, modulo to addition, right? And if you talk about x2, so that is m0 plus m2, so 0 plus 1, that will be 1. Over here, if you talk about output x1, x2, then that will be 1, 1, 0 addition, that will be x1. So 2 times 1 means 0. And x2 is m0 plus m2, so 1 plus 0, that is 1. Over here, we don't have m2, so you cannot calculate output, right? Now, let me explain in which state we have this situation. So if you talk about state, then you see state is based on m0 and m1. That is based on output of memory element, right? So here memory element that is there with m0, m1. Output of ff1 and ff2, that is m0, m1. So that will define state. So as and when we have input 1 at the time, here state is m0, m1, that is 0, 0. 0, 0 means we have state A. For 0, 1 we have state B. For 1, 0 we have state C. And for 1, 1 we have state D. So here for 0, 0 we have state A. Over here state will be 0, 1 means B. Over here state will be D. 1, 1 means D. And over here, even though you don't have input, which is don't care, you can say next state, that will be 1, 0 means C, right? Now, let me explain how to write output. You can observe output is x1, x2. In encoder also, I have shown, see output is x1, x2, right? So as if we have message that is 110, at that time, our output that will be x1, x2, x1, x2, and x1, x2. See here we have 3 message bits. So 3 times there will be output that is x1, x2, x1, x2. Here we will be having x1, x2 with first one. So that is 1, 1. Then for second one, x1, x2 is 0, 1. And for next 0, x1, x2 is 0, 1. So you can observe here our output is of 6 bits and our message is of 3 bits. So based on that, one can say code rate, that is 3 divided by 6 means half, right? Now let me explain next parameter, that is code tree. To understand code tree, there are few basics that you need to understand. See here, I will plot code tree for given message. See in code tree, if you have input which is 1, in that case, you should draw step down line. If you have input which is 0, in that case, you should draw step up line. Let me explain how. See, initially, here, if you observe, we have state A. So this is my first line. And at last, I will represent state A. Now, if you insert logic 1, that is M2, then input is logic 1. So here there should be step down line. And here we need to write output. See here output is x1, x2, that is 1, 1. And at last we need to write next state, that is state B. Now with this state B, if you insert input that is 1. So in that case, step down line that we need to draw. I have told you if input is 1, step down line. And with this step down line, you need to write output that is 0, 1. And next state will be state D. So note down state D over here. Now our input is logic 0. For logic 0 input, there will be step up. So here I need to have step up line. And along with the step up line, here we need to write output that is 0, 1. And here next state, that will be state C. Now we don't have input, so we cannot plot further code tree. So that is the process that you need to follow for code tree, right? Now let me explain next parameter. See next parameter, that is code trellis. To understand code trellis, you need to make a table And in that table, you need to identify M0, M1, M2 and X1, X2. And based on M0, M1, M2, one can understand current state and next state. So once you identify this table, you can plot code trellis and state diagram. See here, current state that will be based on M0 and M1. Current state that will be based on M0 and M1. And next state that will be based on M1, M2. Let me explain how. See, here in encoder, we are inserting input over here. So current state that will be M0, M1. That is the state of this flip-flop. But when you insert next bit, at the time, this M2 that is getting shifted over here and M1 that is getting shifted over here. So next state that will be M1, M2, right? So here, next state that will be M1, M2. Now see with M0, M1, M2, there will be in total 8 combinations. So I have written 0, 0, 0 to 1, 1, 1. Now let me write down current state. See current state is M0, M1. 0, 0 means state A. 0, 1 means state B. 1, 0 means state C. 1, 1 means state D. Right. If you talk about next state, then that will be M1, M2. So 0, 0 A, 0, 1 B, 1, 0 C, 1, 1 D, 0, 0 A, 0, 1 B, 1, 0 C, 1, 1 D. That is how one can understand current state and next state. See output X1 and X2 that one can understand based on this connection. See this X1 that is M0 plus M1 plus M2. So let me explain X1 calculation first. X1 is addition of these 3 bits. So 0, 0, 0 that is 0, 0, 0, 1, 1, 0, 1, 0, 1, 0, double 1, 2 ones are there means 0, 1, 0, 0, 1, 1, 0, 1, 2 ones are there means 0, double 1, 0, 2 ones are there means 0 and triple 1. If you have odd number of ones, then XOR operation is 1. Now let us identify X2. See what is X2? X2 that is addition of M0 and M2. So here now I'll calculate X2 addition of M0 and M2. So 0, 0, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 0. So that is how we have output, current state and next state. Now I'll explain you code trellis. See to understand code trellis, first of all you need to understand how we plot line. So here in code trellis, we will be having input state over here. So let me mention state A, state B, state C and state D. That will be current state, right? So here we have current state and over this side we will be having next state. So here I'll be making next state A, B, C and D. So this will be next state. Now here there are few basics that you need to understand. See if you have solid line, let me write this. If you have solid line, then you can say here our input is logic 0. And if you have dash line, then one can say our input that is logic 1, right? So first of all, what I'll do is I'll plot lines for input 0. Now see, let us consider current state is A, input is logic 0, current state is A, input is M2, that is logic 0, then next state will be A. So here we need to have solid line from A to A, and over here we need to note down output. So here we need to note down output. What is output? If you have current state A, input 0, output X1, X2 is 0, 0. So note down 0, 0. Now let us consider current state B, input 0. Current state B, input 0, next state will be C. So B to C will be having solid line, and over here output will be 1 0. So output will be 1 0. Now let us consider here we have state C and input is 0. So state C, input is 0, next state will be A. So current state is C, input 0 means solid line, next state will be A. Along with the direction, you need to write output, that is 1 1. So let me note down 1 1. Now with current state D, input 0. Current state D, input 0, next state C. Current state D, input 0, solid line, next state C. Right. And here, what is output? Output is 0 1. Right. So let me note down 0 1. Now, what I'll do is I'll identify input logic 1 with all the current state. So now I'll plot dashed line. See, current state A, input 1, next state B. Current state A, input 1, then next state will be B. And here we need to have output on the line, that is 1 1. Now current state B, input 1. Current state B, input 1, next state will be D. So current state B, input 1 means dash line, next state will be D. Over here we need to note down output. Current state B, input 1, output will be 0 1. So let me note down 0 1. See, current state C, input 1. Current state C, input 1, next state will be B. Current state C, input 1, next state will be B. So here we need to plot dashed line, and on the line we need to write output. So output will be 0 0. Right. Now current state is D, input 1. If current state is D, input 1, next state will be D. So by dashed line, let me have a line from D to D, and output is 1 0. So here I'll note down 1 0. So that is how one can plot code trellis. Right. Now let me explain how to plot state diagram. See, method is same, just we need to have different diagram. Let me explain that. See, here in state diagram, first of all, you just note down states. Here we have state A, here we have state B, here we have state C, and here we have state D. That is how note down states first. Now, here in state diagram, first of all, you need to understand lines. Like you see, here I'll be plotting solid line as if input is 0. And I'll plot dashed line as if input is logic 1. Right. So again, see, with state A, first of all, let us have input 0. So current state A, input 0, next state will be A. So solid line from A to A. And on this line, we need to have output, that is 0 0. Now see here, current state B, input 0, next state C. Current state B, input 0 means solid line, next state C. And output is 1 0. So here note down 1 0. Now current state C, input 0, next state A. Current state C, input 0 means solid line, next state A. Current state C, input 0, next state A, output is 1 1. Note down 1 1 here. Current state D, input 0. Current state D, input 0, next state C. So here we will be having solid line. And on this line, current state D, input 0, next state C, and output is 0 1. So note down 0 1 over here. Similarly, now for input 1, I'll plot lines. So current state A, input 1. Current state A, input 1, next state B. So now I'll plot dashed line, you can observe. And on the line, we need to write output, that is 1 1. Now see current state B input 1. Current state B input 1, next state D. So B to D through dash line. Current state B input 1, next state D output is 0 1. So note down 0 1. Current state C input 1. Current state C input 1, next state will be B. So from C to B we need to draw line, and here output will be 0 0. So let me note down 0 0. Now see current state D input 1, then it will be remaining in state D only. So close loop by dash line that we need to have, and output is 1 0. So that is how one can draw state diagram, right? So state diagram and code trellis both are having similar diagram only, but representation way is different, right? And that one can have based on this table. So this is how one can understand convolutional code, and using convolutional code one can understand code trellis. See this code trellis, that is very essential, and using this code trellis one can make Viterbi algorithm, and using Viterbi algorithm one can detect the error as well as one can correct the error. So in future coming videos I'll explain you Viterbi algorithm using code trellis that will resolve your understanding further. I hope you have enjoyed this video. Still, if you have any confusion, just place that in comment section. I'll be happy to help you. Thank you so much for watching this video.